Okay, we're talking about fractional or rational exponents. A rational exponent is just another way to write a radical. The numerator represents the power, the denominator represents the root. Here's the basics of it. The denominator is going to become the root, the numerator is going to stay the power. So x to the a over b is the b root of x to the a. Other ways to say it, you can put the a, if it's an exponent inside a radical, it can go outside. Either way. Numerator is the power, stays with the base. The denominator is the root or the index. They're the same thing. Okay, let's take a look at a few. So you're going to take the square root of x to the fifth. That's what this boils down to. Now remember, we just don't write the 2 there, but that's what's happening. This becomes the root, this becomes the power. So you try this one and try these two real quick. Pause here, work them out, and then come back and check your answers. Okay, so a to the 2 over 3 is the cube root of a squared. X to the 1/2 is simply the square root of x, because there is a 2 there and a 1 there that we just don't write. So let's go the other direction. So this will become the denominator, and this will stay there. So it's w to the 7 over 3. You try the next two, please. Okay, so this would become x to the 2 over 4, but we can reduce 2 over 4 to the 1/2. And as we just said, you don't have to go back and do this, but x to the 1/2 is the square root of x. So the fourth root of x squared is equivalent to the square root of x for all numbers. Just a random thing. That's how you can sometimes convert different indexes to that. So this one would simply be y to the 11 over 6. Okay, let's try it with some numbers. So what this is saying is essentially the cube root of 8 squared. Might be easier to see looking at it like that. Well, the cube root of 8 is 2, and 2 squared is 4. So do that with the next one. So here you're going to do the square root of 16 and raise that to the third power. Here, the third root of 27 and raise it to the second power. Try those out, please. Okay, so you're going to change it to that. And the square root of 16 is 4. And 4 cubed is 64. So this one, you're going to take the cube root of 27 and then square it. The cube root of 27 is 3. 3 squared is 9. Should make a little sense. If the fraction is less than 1, then you're going to reduce the number from 8 to 4 here. If it's over 1, you're going to increase the number. 16 became 64. So 2 over 3 is less than 1, so 27 is going to go down to 9. Okay, on these, you're just actually doing them separately. So you're going to end up doing that. Now the big trick is here. We can calculate this like we just did. We'll take the cube root of 125 and then raise that to the fourth power. Here you're going to do 3 times 4 over 3. 3 times 4 is 12. Divided by 3 is going to be 4. So this is going to become x to the fourth. This is our power to a power. You multiply the powers. So 3 times 4 over 3 is just 4. And the cube root of 125 is 5. 5 to the fourth power is 625. Okay, you try the next two, work these two out, and come back and check your answers. Okay, so we'd have 64 to the 1/3, which we can compute. X to the 6 to the 1 over 3. 6 times 1 over 3 is going to be 2. So you have that x squared. And the cube root of 64 is 4. Same thing here. 10 times 5 over 2 would end up being 25. And here you can think about, I'm going to take the square root of 4, which is 2, and raise that to the 5th power, which will make it 32. Okay. So a quick summary, x to the 1/2 is just taking the square root. X to the 1/3 is taking the cube root. And x to the 2 over 3 is taking the cube root and then squaring it. Okay, that's fractional exponents. Good luck.